2.1.2, we're going to talk about what it means to transform data. So namely, we have all these kind of summary statistics, right? You take a data set and you might want to calculate the mean or the median or Q1 or the standard deviation. But what if you then need to convert that data, right? So maybe you measured it in inches, but you need to convert it to feet or to centimeters. So that would be an example of needing to transform the data. And how does that impact all those summary statistics? Do you have to just recalculate new summary statistics, or is there some sort of a transformation that we can predict will happen with the summary statistics as well? All right. And so we're just going to kind of jump right into it. You definitely want to copy down what's in the yellow boxes and green boxes normally. That'll generally be like definitions of important vocab terms or formulas. So the effect of adding or subtracting a constant. If we add or subtract a constant from each observation, the first thing says it's going to add that same or subtract that same constant to measures of center and location. So that's mean, median, quartiles, percentiles. But it does not change the measures of spread. So things like the range, the IQR, and the standard deviation would remain the same. The way I kind of think about this is in terms of like functions, algebraic function, because all our distribution, what we'll find out in a little bit is that we use these things called density functions, and those are just the curves I draw to represent my distribution. So they happen to be functions as well. So we can kind of go back to our algebraic understanding of the graphs of functions. And if you can remember how adding or subtracting a constant to those functions impacted them, it just gave them a shift. So if I add A to every piece of data just gets shifted to the right in that case by A units, which means our measures of center, like the mean, got shifted over A units as well, right? But what didn't change is how spread out our distribution is, right? So you can still see, like the range is still going to be the same range. When you take the max and you subtract the min, you're still going to get the same thing because everything shifted up A units. So that's why measures of center and location are all increased or decreased by that constant A, whereas measures of spread are not impacted. So let's do an example so you can kind of get some hard evidence of that. So this is sort of already a worked through example, and I'm just going to kind of analyze the data for you. So here is a graph and some summary statistics for a sample of 30 test scores where the maximum possible score on the test was 50 points. And so you kind of have a variable distribution here. I'll draw a curve to sort of represent the overall trend. And down here we're given our summary statistics. We have the mean. Mean score was 35.8. Standard deviation was 8.17. Minimum score was 12. First quartile 32. The median score, meaning half students above, half below, was 37. Q3, or the 75th percentile, is 41. High score, the max, is 48. We have an IQR interquartile range of 9 and a range of 36. All right, so suppose the teacher then felt they needed to give a grade boost, so they decided to give everybody an increase of 5 points. Everybody gets 5 more points. Now let's look at these two distributions. So you can see they are the exact same distribution. The second one is just shifted to the right by 5 points. So let's see what happens in the summary statistics. The mean increased by 5 points. Standard deviation, which is a measure of spread, remains the exact same, not impacted. Minimum increased 5 points, Q1 increased Median increased, Q3 increased, the max increased. Those are all measures of position. IQR stays the same, range stays the same. So when you're just adding a constant to a distribution, measures of position get that constant added or subtracted as well, whereas measures of spread do not change. All right, so the other thing we could do is multiply or divide by a constant. And how does that impact our distribution? So we're going to multiply each observation by the same number b, or divide by b, depending. That multiplies or divides measures of center and location by b. It also multiplies or divides measures of spread by the absolute value of b. It will not change the overall shape of the distribution. It may distort it, meaning it can compress it, or it can expand it, it can stretch it out, but it won't change the overall shape, meaning if it was roughly symmetric, it's still going to be roughly symmetric. If it was a right skew, it's still going to be a right skew. So we use that same data set, and in this case, since the distribution, the tests were out of 50, let's say we wanted to find the percent score. Well, since it's out of 50, all we would have to do is multiply each score by 2 to get its percent. So I'm just taking every individual score and I'm multiplying it by 2. You can see what that does visually to the graphs. So I'll kind of try and draw the shape of the distribution. We had this sort of left skewed distribution. We still get that left skew, it's just a little distorted. In this case, it's stretched out by a factor of 2. But the overall shape maintains its integrity. It still has a left skew. Let's see what else. So the first row is the original score out of 50, and the second row is the score times 2, so it's the percent. So you can see the mean gets multiplied by 2. Standard deviation gets multiplied by 2. All these measures of position get multiplied by 2. So does the IQR, so does the range. So multiplication affects everything. All right. Now that we know that, we're going to try a little bit more of an algebraic example. So this is a quaint example about taxi cabs when we used to have those. Now it's just Uber. It says in 2010, taxi cabs in New York charged an initial fee of $2.50 plus $2 per mile. In equation form, that's going to come out, like this. Fare equals $2.50 plus 2 times miles. At the end of a month, a businessman collects all his taxicab receipts and calculates some numerical summaries. The mean fare he paid was $15.45 with a standard deviation of 10.20. So I'm just going to make a note of that. All right. What are the mean and standard deviation of the lengths of his cab ride in miles? Well, the first thing I would point out is that the equation we have is for the total fare. And they have miles here. That miles refers to the length, right? And so what we're asked about is now the lengths of those rides. So I want to take that equation, I want to manipulate it so that I've isolated length. So let's go ahead and do that. So the first thing I'm going to do is subtract that 250. So I'm going to get 2 times the length equals the fare minus that 250. And then to isolate the length, I'm going to divide everything by 2. So now I have the length of my rides, which will be in miles, equals, I'm going to rewrite fare as 1/2 fare, which is going to be in dollars, minus the 250 also got divided by 2, so it becomes the 125. All right, so now I have this equation for length, and you can think of this equation for length as a transformation to fare, which I already have my data on, right? So I'm taking the fare, I'm multiplying it by half, and then I'm subtracting $1.25. So two transformations there. There's a multiplication and there's a subtraction. And so what we can do is apply what we know about transformations of center and transformations of spread using this formula. So first of all, measures of center are impacted by multiplying, and they're also impacted by adding and subtracting. Okay? So to get my new mean, I'm going to apply both transformations to my old mean. So my new mean length so I'll take length equals half of my old mean length, which is 1545, minus $1.25. So I'm going to throw that in the calculator. I don't think I need to display it on the screen. You guys can handle doing that. And so remember, this is going to give us an answer in miles. So this is 6.475 miles. All right, so the mean length in miles is 6.475 miles. Now I need my new standard deviation for miles. So standard deviation is a measure of spread. We know that measures of spread are impacted by multiplying, but measures of spread are not impacted by addition or subtraction. Meaning when I want to apply that transformation formula to the standard deviation, I'm going to ignore the minus 1.25 because that's just a subtraction of a constant, and measures of spread are not impacted by subtracting. So all I need to do to compute my new standard deviation is take my standard deviation for fare and divide it by 2, or multiply by 1/2. Okay. So that's going to give me 1020 divided by 2 is 510. So my new standard deviation is 5.10 miles. That's my answer. All right, last thing I got for you is a student example. Go ahead and pause on the screen, give this one a try, and we'll go over it in class next time. See you then.